Well, thank you guys for coming out. Welcome to SolidWorks Duct Tape and Baling Wire, or as we call it around our office, Redneck Workarounds. My name is Josh Altergott, Technical Support Manager for Computer-Aided Technology. We're a SolidWorks reseller out of we're located in the Midwest. In particular, we're in the Chicagoland area. Me and my counterpart here, Adrian Fanjoy, who I'll let him introduce himself there. No?
I'm the Technical Services Director for Computer-Aided Technology, and I apologize for my voice. It went out sometime last night. If it gets too bad, they're going to tell me, and we have a backup for me in the back of the room, so we won't subject you to it too much if we can avoid it. But we're hoping to show you guys some interesting ways to solve SolidWorks problems and a few other problems as well. You can't stick it all to SolidWorks. You guys are going to get bored of SolidWorks by the end of the week. So we're going to give you a little break in that once in a while during this presentation.
All right.
This is pretty much the agenda. We're going to show you a problem. We're going to show you a solution to that problem. Hopefully it's a creative solution to that problem. And then we're going to do it again until we either run out of solutions and problems or time, whichever comes first. Okay?
Yeah.
So it should be kind of fun, we're hoping.
And what do you do with an old U-Haul truck and a bunch of mid-'80s Chevy parts? Come up with a redneck limo. All right, so our first problem that we're going to talk about here is imported part orientation. Problem that you got is your part is imported, has the wrong orientation, location of the origin's not where you want. You guys have all seen this on parts that you've downloaded. Everything's askew from where it needs to be. So how do we correct this? Well, solution step one is to create a sketch and to dictate our new orientation. We started on a plane that we want or create a reference plane, generate the sketch with our proper orientation lines there. Next thing that we do is we go ahead and we insert a coordinate system. Through the reference geometry area, setting up our origin and our axis. And next thing that we do is we go ahead and we export that file, setting the option for the output coordinate system. So when you go in to export that file, step, IGES, Parasol, whatever it might be, hit the options button, and you'll see that output coordinate system that you see in the bottom part of that screenshot. Choose the new one that you just created, and then the step 4 is going to be to import that file that you just saved out. So we're basically round tripping the file at that point in time, and we're going to get a file that's in the proper orientation for us.
We actually had this issue come into the support line. Someone wanted to change the icon of the SolidWorks icon from the standard one to a Pac-Man. Okay? So we'll let them do that, right? We'll show them how to do it. It's not really that hard to do, but it's kind of fun. What we do is we create a new SolidWorks shortcut. We go to the SolidWorks executable, right-click it, and create a shortcut. When you create a shortcut, you get the option to change the icon. You can change it to anything you want. There's a whole list of icons in the operating system you can choose from. There are tools to make new icons. What some of our customers have done in the past, everyone's seen 2015 SolidWorks icon has the year in it. Some of our customers have put the years of the past versions in too, so they can have multiple versions and they know which icon to hit for which version they want to use. So that can help out quite a bit. Remember, you can use these tools to create your own icons. They're all over the web, and they're all free, basically.
All right, so you're looking for the easiest way to modify your SolidWorks toolbars. Everybody knows we don't want to have a screen that looks like this. So what's the easiest way to go in and modify the toolbars? We can right-click, go to Customize, and do all that, or the Alt key. Control, Alt, Tab, they all do something different inside SolidWorks. In this case, if you hold down the Alt key, click on an icon, and drag your unwanted icon off the toolbar, you get the red X next to it, it's gone at that point in time. Other option that we have, option 2, is if we want to move that icon, you hold down the Alt key and you drag that to where you want. You can see the divider bar that's all the way on the right-hand side there. that's what it's going to do. It's going to show you where that's going to move to. You let go of your mouse, your left mouse button. You let go of the Alt key. Your icon's been changed to a new position at that point in time.
All right. We told you we'd give you some stuff that's not exactly SolidWorks. But what happens, excuse me, what happens if you want a nice flat screen TV like your neighbors and you don't have a flat screen TV? It's pretty interesting. Oh, and there's some really good stuff here, really. This is my favorite. It's hanging from Romex, and there's where your outlet is. That's the cable box that apparently was not moved before they punched the hole in the wall. Nor was the carpet. And you see that cable running across the floor into the next room. We're not sure what that's powering, or if that's where the power's coming from. But he couldn't, because that's where it's plugged in. I mean, it's just a disaster, right? And we're not sure the door will open. But it looked good from the front, didn't it? Look at that. That was pretty. There we go.
All right, so next thing that we'll talk about here is efficient sketching tips. You want to make sketches as quickly and efficiently as possible. So how do we do that inside of SolidWorks? There's lots of little tricks out there that, they aren't in the essentials classes. They're sometimes buried in the help menu. And we're going to show you a few of those. So solution one, you can use trim to extend. How many people knew you could use trim to extend? Oh, that's a good number of people. Nice. So you can click and drag the end of a line or arc to the next entity in a sketch. You got to be set for trim to closest, which if you use SolidWorks for a long time, you know that used to be the only option you had. Using the line tool to add arcs. When you're in the line tool, sketch your first line, the click-click method versus click-drag. When creating your next line, move back to the end point and pull it out. It's going to switch to a tangent arc for you. That's one thing. It is going to be a tangent arc. You got all 8 different positions that we see on the screen there, and the results vary depending on where you start and end your arc at. And for people who accidentally get into the screen, the hotkey for this is A, and you can see that in that other screenshot there. When you can right-click, you'll see switch to arc or switch to line. A is the hotkey for that. Modify sketch. This is an old school one. And things are old inside of SolidWorks when they're not in the property manager anymore. This guy's still a pop-up menu when you activate it. And this is great. It can be used to move, rotate, scale, mirror your sketch at any point in time. The only limitation to this is don't have any existing relationships. If it's tied down to an origin or dimension to some other object, it won't do it. But if it's a free-floating sketch, you'll have the ability to utilize all those tools. Just a left or right click will give you different options with this. So creating virtual sharps inside SolidWorks in your sketches. A couple different ways to get this done. First thing is you can control select 2 entities in a sketch. Select the point tool from the toolbar. So you highlight the 2 items that you see in the left there. You hit the point tool, you get the virtual sharp that you see on the right. Other way of doing this is if you're already in the dimension command. So if you're in Smart Dimension, there's a Find Intersection option there. It allows you to pick both the lines, and it'll create the virtual sharp for you on the fly as well. So as with a lot of things inside of SolidWorks, there's always more than one way to get the job done. And that's kind of what we're here to show you. All right. Selecting silhouette edges. Sometimes, it just doesn't work. I don't know why, but it just doesn't always kick in the way that you want it to. So what other ways can you do this? You can add in construction geometry to your existing sketches and add relations to that geometry. I like doing this as well because now I'm locked into a solid piece of geometry. I can put some equations, I can control this thing with a design table, and I know it's always tied back to that sketch entity versus being tied to a silhouette edge that could change or go away depending on how fillets and other items are made inside of my model.
All right. How many people use network licensing right now? Holy crap.
That's a lot of people.
That's a lot of people. All right. Well, as you all know, at some time you're going to want to move your license server to another machine, and it's always a disruptive process. Okay? So what can we do to make this happen a little more efficiently? And we have a couple ideas for it. Okay? My favorite is to export the registry key. We have it listed for you right there. When you export that, you get the location of your server, the name and the port of your server. Once you're at that point and you've exported it, you now have a .reg file that is in essence a text file that you can open up with a text editor like Notepad. At that point, change the text in the file to your new server name. Okay? Now you have a .reg file that's got your new server in it that you can import into your computer. Okay? Now you're pointing at the new server. But the real problem is you're in network licensing, you got a lot of users. You don't want to go to each one of those and push the button and dump the license one at a time. We got network licenses for efficiency, not so you could go all over the place to make changes. So, things that you can do. You can create a batch file. This is the syntax, pointing to the registry file that you had just created. That will allow you to, by initiating the batch file, dump it onto the computer. So now you got to find a way to get that batch file to folks. Either email it to them. If your email lets you send batch files through it, you need to talk about security with your IT folks. You can offer it on an internal website. That's one way to do it. My favorite is most of you will have a login script that happens every time you log in. Just drop that batch file or the syntax into that login script and just leave it there for a couple of weeks. Then every time people launch or log into your system, their registry will be changed. They will be pointed to the new server. You leave that in there for a couple of weeks. All of a sudden, everyone's updated and you didn't have to do much of nothing. Very simple, easy process to get it to everybody. If someone went on vacation for 3 weeks, he'll be screwed up, but he deserves it. He was gone. And he was probably in Hawaii, and we're jealous, right?
All right, so the next problem is you got a complex sheet metal part that you need to form incrementally. Well, so that's not the sheet metal part we're looking for. That's the sheet metal part we're looking for there. So we got a part that we want to form incrementally. We want to form this in a series of stepped bends. How do we do that? Solution for this one is using sketches in the split line tool. We're able to break the faces we wanted where we want our bends at. So by putting in a bunch of split lines, we can see we put all the lines across those faces. That's where each one of our bends are going to be. In some cases, if we have areas where there's two tabs that really need to be tied together, we can add in a bridge of material between the two ears, as it's shown in blue there. And this allows them to flatten together. Just another little trick in there. And then we use convert to sheet metal. Tell it to collect all bends to get a part that has your incremental bends inside of it. And the last thing is flatten this out. And you can see with this part here, we see all the bend center lines that are stacked up in there. Some of the bends we suppressed just so you could see how it does bend up each of those individual features. And you got a part that now has incremental bending inside of it. Pretty cool. All right.
This happened a lot in a couple of versions of SolidWorks. I think it happened most in 12. Yeah. But it still happens once in a while where the measure dialog, in reality, think of it like this. You got two monitors. One of them's your laptop. You've done a lot of work with SolidWorks. You get up and you go somewhere, and now you've got one monitor, and your measure dialog box is gone. It doesn't come up. In reality, it's coming up on the other screen, and it hasn't figured out that you've only got one screen yet. So it's just hanging out there in space, and you can't reach it. Your mouse won't even go over there. So how do we fix this? Oh yeah, by the way, We're hacking through the registry on some of these, so I'm not responsible. Okay. Option 1, change the resolution to your screen to the max allowed. Sometimes you catch a little corner of it and you get lucky. It kind of fits in, okay? But more fun, go into the registry editor. Does everyone know how to edit the registry? Come see me if you don't. It's pretty easy. And you go to H key current, Go to H key current user, software, SolidWorks, and the version you're on, general, and there's a measure dialog position key. A little bit hard to see. But you just delete the key. Then you relaunch SolidWorks, and that forces it to rebuild that key, and it's going to rebuild it back to the default position, and it'll be on your monitor. And you'll get that dialog back. So.
By the way, there's lots of other cool things that you can do inside of here that, may or may not affect your other users that you're working with on a regular basis. Just saying.
There we go.
All right. So next real world problem that we got here. I got a new hunting trailer. Need to move it to the hunting property. How do we get this thing moved? It's a big old beast. You find the appropriate size vehicle. Well, or what you think is the appropriate size vehicle for that. This, kind of like our other one here, we got some issues with this. Got to convert the gooseneck, so lay down the gate. That'll work out fine for that. Wiring? Yeah, we don't need any wiring. Somebody mentioned chains? Yes, there are some chains in there. They must have run a sim study on this to know that they needed a little bit of extra support. So,
and that the S-hook would hold.
Well, and really a little bit of extra support. I personally like the dowel rod that's holding it through the trailer hitch at that point. No. Yeah, turning radius, that might be an issue, seeing as your front tires are off the ground a little bit there. And it's, I hope you don't want the back windows at that point in time either. You're going to have a convertible before too long. So, and there's mountains in the background, so who knows where this thing's going. All right.
All right. Now, we've changed the licensing, the activation method recently. A lot of you have gotten new serial numbers. So many of you are on network licensing, you may have noticed that the serial numbers have changed a little bit. Part of that allows the home licensing to work differently. So some of you will not have this problem, but a lot of people do, that you cannot upgrade a home use license if you're using, you can't upgrade it
at all.
That's the way it was in the past. They've made some changes to make that happen a little better recently, but you may not have been privy to it quite yet. Now, with network licensing, you have this neat little feature. You have another valid serial number, and that's what we're going to play with here. So what happens is it goes up, tells you can't upgrade it, and what we do is we go into Add Remove Programs, and we modify our install. Now, we're at home right now, okay? And we're modifying our install, and we change the serial number of our home use license to the same serial number as our network license. Now, it will let you upgrade because it's got a valid serial number, not a home use serial number. You won't be able to launch the program because you don't have a server, right? You're not anywhere close to your network. But when the upgrade's done, you can go back in here, modify it again, change it back to your home use license, and it will work.
Now, the other thing with this, when you go and modify the serial number, you don't have to go through the whole installation process. You go to modify, it asks you for the serial number, you hit next, As soon as it gets to the screen where it says install, go ahead and hit cancel at that point in time. Serial number has been committed to the registry by that point.
Exactly. Yep, there we go.
All right. Everybody's seen this one, right? Failed to save document. Yeah, it usually happens about 3 hours into your work, and you realize, oh, I really need to save this document, and it won't save at that point in time. So how do we get around this? There's quite a few different solutions for this, and when we're working on tech support, we're trying all of these with you to figure out what one is going to work. Every situation seems to be a little bit different. So one of the first things we like to do is start simple. Does save all work? If you're in an assembly, does save all work? This is going to save every last part file, assembly file, subassembly, and see if that does the trick for you. If that does it, then you'll probably be able to save the top level. Try to use a control Q. Perform a forced regeneration of the model. See if we get a rebuild error at that point in time. Could have a rebuild error with our file. Do you have configurations? If you have configurations, this one's got just a few. Cycle through some of those configurations. See if there's an error with any of those configurations. If you got it in the design table, edit the design table, exit out, see if it's giving you any warnings that says, this row will not work or this configuration will not work. Find and modify the problems with it that way. Did you just edit a part? If you were working inside of an assembly, did you go into edit part, make a change to a sketch or something like that? If you did, open up that part file, rebuild it, save it, see if there's any errors with it. Go back to your assembly, rebuild it, try and save it again at that point in time. Turn off all add-ins. As odd as that sounds, and we talk about this in our performance presentations that we give, if you have add-ins on that you aren't using, turn them off. If you aren't using simulation every day, turn it off. Get rid of those, see if that clears up the issue for you. Sometimes having just that little bit of overhead can hang you up with saving out some of your files. Resave the assembly with a new name to a new location, kind of like you do with the Salvation Army couch. Pack and go. You can use SolidWorks Pack and Go to gather up all of the files, save them out to a new folder. In particular, if you were working on the network, save these all out to a local drive at that point in time. See if saving them out to someplace other than where they're at is part of the problem. Next thing that you can do, insert the part or assembly into a new assembly. Save that new top level. Maybe that'll get you your save that you're looking for at that point in time. Can you save any of the subparts? Like we said before, we want to go in and open up the subassembly files, try saving those out, see if that works. Open up some of the part files, make sure all of those operate as they should. And other option that you have here is SolidWorks Backup. Go in, turn it on, turn down the number or the amount of time before its next backup. Browse that location, see where that backup's at, open it up, see if it's valid for where you're at that point in time, and use that backup instead of the file that's not working properly for you. So that's a pretty good laundry list of items there. There's a few more in our bag of tricks, so if you got any more, please ask me.
It's important to realize. Turn that off. It's important to realize that Josh has been doing this for almost 13 years.
No, I think it's 13 years this week.
13 years this week. And each one of those options on the failed to save document section has been used in our support process to help someone. We know each and every one of them work in their given circumstances. So they're very, very important tools that we have in our toolbox that we've developed over the years, or that he developed over the years. Now, what I've run into recently, and the reason we added this section to the slide, is because I had some automatic things happening on my computer that I didn't realize where it came from. Just boxes popping up on the screen, and I don't know why it was happening. I don't know what the program was that was starting it. It was just random junk, for lack of a better word. So when things are happening on startup automatically in the operating system, how do you fix that if you can't just take care of it easily? If you can't just say, don't show me this again or something like that.
Yeah, and the problem with this too is anything that's running in the background, it's stuff that's slowing you down in the day-to-day process of working with SolidWorks as well at that point in time. It's taking overhead, it's taking CPU, it's taking RAM.
Exactly. So, one thing we can do, the startup folder. In Win 7, the startup folder is real quick and easy to get to. Anything in that startup folder is going to pop up when the user logs in and run. It's either going to run in the background or it's going to do some initial task for you. Lots of stuff gets dropped in there for startup programs, and you can see there's a couple of things from SolidWorks that get dropped in there as well. The background downloader and the fast start. Okay? Now, if you go to this directory on either Win 8 or Win 7, those files are in there as well. You just delete them. In Win 7, you can delete them right from here, or you go to this directory and delete them out of there. They will not start up again. Okay? Make sure you want them not to start up again. There we go. These applications that pop up, Microsoft Communicator is the one I'm talking about, because when it launches automatically, all of a sudden everyone knows you're there and they start trying to talk to you. You don't always want that.
Yeah, Adrian's the boss. He doesn't want anybody to talk to him.
Especially you.
Exactly.
All right, so you can go into some of these tools, some of them, not all of them, go into the options, and they have an option to turn that off. That's great, makes it simple and easy. Hello, Peter. The task scheduler. Stuff gets dropped in there, but when stuff gets dropped in here that you don't want running, you got to make sure it's what you don't want running, because there's some important stuff going on in here as well, and you don't want to turn off the important stuff. It'll give you hassles later on that you won't be able to identify or figure out why they occurred. Okay? There's a lot of stuff that's just required in here, and a lot of stuff that the operating system runs that, well, you find the value individually. Everyone is different. MS Config in the Task Manager. Now, there's a tool called MS Config. Has anyone used it before? Wow, that's a big number for that one too.
We got smart people in this group.
And you.
Yeah, and me. It's always good to know. All
right. So in Win 7, when you use the MS Config tool, all you do is go to your run command and type in MS Config. Son of a... You hit me with a rubber band. The tool will come up, and in Win 7, there's a Startup tab, and you can disable any of the things starting up in that tab. Here you'll see I've got Realtek HD Audio Manager, the Adobe Reader, Install Shield, and the SolidWorks Background Loader. Once they're in here, but all right. In Win 8, you go to the Startup, and it's just going to take you to the Task Manager that you reach by right-clicking in the toolbar down at the bottom. So you don't need the MS Config. You're just going to go to your Task Manager and get to the Startup page and see all of this stuff. Okay? Some of this I can't even identify, but here was the one that killed me. Install validator for National Instruments software. I don't know who National Instruments is. I don't know how they loaded stuff on my machine, and I was pretty upset about it starting up in the background automatically. Does anybody know who this is? Oh, aren't you all smart? All right. It's like a programming backend. It's a company that makes software as a programming tool. But for me, do you guys have kids? Is that why you know about this? They make the tool. There's a thing called Lego Mindstorms. It's a robotics thing they used in the first robotics competition. I bought the Mindstorms package for my kid. It's got a programming mechanism that is built off of their tool. So when I loaded the programming from Lego, I thought I would have Lego stuff on my computer. I had theirs. It's just the back end for the tool for the toy, right? So things get on your computer that you don't realize are there, sometimes for completely legitimate reasons and sometimes not. In this case, I'm done with that because we put it on our computer at home and I don't need it on my laptop anymore. But
bottom line is, Google these things before you delete them is what it amounts to.
that's how I figured it out. Yep. And the registry. This is where it gets kind of dangerous, but fun as well. And I'll show you the fun part in a minute. But how many people have admin rights to their machine? Wow, this is great. I love this crowd. How many people's IT department is pissed off because of that? Yeah, okay. Just checking. Just checking. Now, chances are if you have admin rights to your machine, you have admin rights to your neighbor's machine too. It's just the way it kind of works, right? Okay. What we can do is go into this key, these two keys, and there will be things listed in there that start automatically. Now, that's my antivirus software. That's that install validator I told you about, communicator. Not a lot of stuff that I wouldn't want in there, but you bring it up into each of these locations. See if there's anything in there that's bothering you or causing you a problem, and just remove the key and you'll be fine. Take it away. There's also current version run. So now we're in HKey local machine was the top one. HKey current user is the second one. Top one launches those apps that launch when the machine is running. The bottom one launches when the user logs in. So how do we use this for evil? Because this is really cool. Because if you put anything in one of these locations that say run once, there's run and then there's run once. When you do an install and it says you got to reboot, a lot of times what it did was it dropped something into run once. So the next time it reboots, it runs it and then wipes it out of here so it doesn't run again and again and again. So what it does is it automatically removes the evidence that you were there. Not only will it launch a program for you automatically, but if you put a picture file, the location to a picture, a JPEG, it will launch the application to view that picture. So you can put anything you want there on your neighbor's computer, and that's what they're going to see. And if they reboot their machine, it'll go away forever. So you can't get caught. And we're real happy about that because we've recently acquired an HR department. Yeah. And it's really crimped our style in a lot of ways. But now,
we can't have as much fun as what we used to, is what it amounts to.
Yeah, we can tell you stories later. All right.
All right. So the next problem that we got a laundry list of crap in the garage. Wife always wants to get rid of all that, so you can see the laundry list of stuff. Most importantly, we got beer. What do we come up with? Come up with this little gem right here. You know, this looks like everyday go-kart, right? Nothing too fancy about it. I think we got to kill the sound on that one.
It had sound.
So this thing's cruising around, looks pretty good. Kids moving around pretty good. How is this thing running? Is the question. I see some 2x4s, some old wagon wheels. Well, yes, there's our steering mechanism. It's a couple of eye bolts and some string. Brakes. It's got a brake. Yeah, really. That's the brakes.
But there's your motor.
There's your drill. Notice the overuse of zip ties. Every time it probably didn't work, you just add a few more. Weed whacker string, you got plenty of that left over? Yeah, there you go. And that thing rolls. Now, how many people are going to go home and try and build one of these? I wanted to build one and bring it here with us, but it wouldn't fit in my suitcase. So. Exactly. So there you go. So there's something fun that you guys can do when you get home. All right, next problem that we got. Services, and more services. How many people have imported a file and all you see is all of these blue lines inside of here? Yeah, almost everybody. So what's the problem with this? We got this file here. You look at it, you go import diagnostic. It tells us there's 251 faulty faces and 586 gaps between faces. Pretty much if you say attempt to heal all, just walk away at that point in time. Just walk away, because that's all that you're going to be able to do. How can we get around this? Pretty easy. We're going to export that file as another neutral file format. Step, IGES, Parasolid, once again, any of the neutral file formats. I had good success with IGES. Every file is a little bit differently. It acts a little bit different is what I found with this. Then what we can do, we can import the file that we just exported, making sure to check the import options when we bring that in. One of the things I always like to point out in here is there is an option for perform full entity check and repair errors. That's the key right there. When we do that, and then we go to our import diagnostics, what we end up with is a file that has either far fewer surfaces and possibly just one solid body. In our case here, it took those 554 surfaces or 541 surfaces and turned it into a single solid body with no errors. Even if you came back and had 1 or 2 holes in this part, it beats the hours that you would spend normally correcting a file. So it's worth the try to, import it 3 or 4 different times, try out different settings, try out different options, because the 10 minutes that you took to do those couple of exports far exceeds far beats the time that you would spend otherwise.
Is anyone else wondering how we figured that out? I mean, what would make you export it when it didn't come in right the first time? But that's what the definition of a redneck workaround is. Something that you wouldn't expect to be valid, actually working. Now, all of you guys seem to have network licensing. You all seem to have IT departments. About half of them are evil. But what we like in these larger environments, these larger design environments, is more consistency with standards. Okay? And one of the downsides in a big environment is that SOLIDWORKS allows the users to make changes in areas that may not be appropriate for, standards or best practices. So how can we get these standards and impose them on our users effectively? One is, what we're going to do is we're going to use the copy settings wizard. We're going to create the environment that we want. We're going to save it out, and we're going to create that registry file from it. Now, it's going to come out as a .sld reg, because that works with the copy settings wizard. All that is a reg file, a .reg file. When you double-click an reg file, as we saw before, it just installs that onto your machine, and that's what you get in your registry. That's a really handy little tool. What we're going to do is change that SLD reg file. We're going to change its name to an reg file. Then, using that same syntax that we did before and that same method, we're going to create either a batch file or input that syntax into a command line or into a login script so that every time the user logs in, that registry file is kicked off and the settings are automatically set to your standard. So if the user changes it, the next time they reboot their machine, it will change back. And they will change it, and the next time they reboot their machine, it'll change back. If we put it in the login script, it'll happen every time they log in. And eventually, because we're all engineers, if it keeps changing and we keep having to change it back, eventually we get lazy and give up, and then we just go with the standard because we are engineers. All right? So that's the key, is to impose it on them in a way that they can't get away with. They can still change it, but just keep pushing it. Just keep pushing it. You'll get the standardization you want.
And all we're pushing here is the SolidWorks system options, by the way. So we're not changing, we're allowing them still to optimize, their menus and change their keyboard shortcuts and all of that. The other thing is when you're doing the system options, before you export that, check the file locations. Make sure there's nothing pointing to a local directory that isn't the same on somebody else's machine as well. So,
thank you.
All right. Problem we have, you have mold or other multi-body part, and you want to know the sizes for purchasing manufacturing. And purchasing manufacturing do not measure things in number of beers, unfortunately. So, step one, what we're going to do, we're going to make our part into a weldment. Pretty simple. Go to the weldment toolbar, hit that icon that says weldment. That's it. That invokes the weldment environment at that point in time. What that does for us is it creates a cut list. It turns our list of solid bodies into a cut list at that point in time. What happens with a cut list is each one of these items has a bounding box. You right-click, you tell it create bounding box, and you can see our screenshot there that shows each one of these items has a bounding box next to it. What that does for us, we can go into the properties of each cut list item at that point in time, and it shows us the overall size as well as the volume and the material for that particular item. So we're able to get material, size, volume. I mean, that's pretty much everything purchasing needs at that point in time to get you the material that you want.
Okay. I don't know why you need to move out of the third floor apartment. I know why I had to do it, and it's deeply personal. You're fairly lazy, which is also true with me, fairly resourceful. You've seen what we've done so far, and you really love your sofa. That wasn't me, but. So what do? See my sofa right there? It's very hard to see what's going on down in here. Can you hit play?
There we go.
3 long ropes, a couple of stout tie downs. And you can slide that puppy all the way down.
I think the only thing better is if you back the truck up into the lawn and just had drop it onto the tailgate at that point in time.
Tell them try that next.
Yeah, exactly. That's what I would.
That's pretty cool, isn't it?
Now, how many people are going to go home and try that one?
Yeah. All right. There you go, bud.
All right. Next one that we got here is flattening out complex sheet metal parts. So we got a complex sheet metal part. We need to flatten that guy out for manufacturing. How do we go about doing that? So what we do, we start off, we use a sweep, loft, whatever other features you need to create the end resulting shape that you're looking for. So we want to get the end result first. It's not going to be a sheet metal part yet at this point in time. And we can see we got some cuts, some lofts, some sweeps in there, all sorts of different operations. Then what do? We create a 3D sketch of each profile. Convert entities inside of each 3D sketch. We get our inside and our outside profiles at that point in time. We can go ahead and delete the original, or the body of the original part at that time, because all we need are these 2 curves. Then we use lofted bends in the new 3D sketches to create that sheet metal part. So you go sheet metal toolbar, lofted bends, you pick your 2 profiles at that point in time, you put your thickness in. End result then is going to be take that new part, test it out, make sure it flattens properly for you. And there you go. Now you got a flattened sheet metal part. And now this works with all sorts of different shapes. I've done it with these helical ones. I've done stuff that goes over curved cylinders. It works out really cool. There's a lot of different items that you can flatten out with this.
So when you're opening, rebuilding, doing any process for an extended period of time in SolidWorks, how many people have seen it just white out on you? Yeah, I knew that would be a big number. How many of you have said, forget it, and just shut it down or reboot it? Yeah, it happens. Okay? Sometimes you have to. Well, but sometimes we get a little anxious about it. The whiteout looks like it means that it's crashing. And we get this signal that it's not responding, and do you want to wait for the program? Not responding does not mean crashed. Not responding means SolidWorks is thinking. It's a good idea at this point to go down, right-click in the menu bar, get that task manager up and see if the SolidWorks item is pulling processor. Because if it's doing stuff, if it's thinking, the last thing you want to do is stop it. It's just taking longer than you would have expected. So One thing that we've helped customers with is we've stalled the time in which the message will come up, that non-responding message. So what we do is we go into the
registry.
Yeah, the registry, thank you. We go into the registry to the desktop, and we find, does it say here real quick? Yeah, the hung app timeout. I don't like the way this slide's set up.
Oh.
All right.
How's it feel to want?
Feels like someone's waiting on their review. All right, so we go there. In this list, this is the problem, in this list, the hung app timeout key will be there. And it's measured in milliseconds. The default is like 5,000. It's like 5 seconds. That screen's going to pop up and tell you that it's not responding. You can change that number to anything you want. What is it that we put in here?
Next slide's got it.
180,000 gives you a 3-minute, 1,000 milliseconds is 1 second. So you can put it anywhere in there. Maybe you want 30 seconds, maybe you want 3 minutes, but it's not going to tell your users that it's not responding. It's going to wait a little bit longer and maybe give them a little bit more time before they get too anxious and get desperate and think that the machine crashed on them or something. That's what's happened more often or not. And we've gotten that in support a lot. People getting frustrated that their machine's crashing, and we found out it was just whiting out after 5 seconds. All right?
All right. Open assembly equals a fail. Error was encountered trying to open in your file. We've all seen this one, kind of like that failed to save document. So how can we get around this message? What we're going to do first, from the open dialog box and the drop down for configurations, we're going to select the advanced configuration button or the advanced configuration option. You're thinking advanced. I didn't have an advanced configuration when I saved this out the last time. This is in there for all assemblies. So what do? We select the option that opens the assembly with everything suppressed. New configuration showing the assembly structure only. You type in the configuration name you want. We call it troubleshooter in this case here. And what does it do for us? The assembly opens up. If the assembly does open up, we know it's not corrupt at that point in time. Then we can start unsuppressing parts, sub-assemblies, and seeing what we got until we find the bad file, the one that's got the rebuild there with it, the one that's got the exclamation mark. Maybe there's a problem with the mates. We'll figure that out as we go through and unsuppress those different items. Use the component properties, find the location of the bad file, open that up, troubleshoot any errors that you have with that individual file at that point in time. All right. So that brings us to the end here. How many people, by the way, we forgot to ask this question. How many people were at mine and Adrian's presentation yesterday? Anybody? Got one. Got two, three. All right.
We got a few.
We got a few. Good deal. We're giving a lot of presentations this week between me, Adrian, and the rest of our team. This is a list of all of them. If you guys want to come to any more of them, we highly suggest you do. I'm going to 120 next, right after this. So feel free to follow me over there. And got a lot of different options for what you guys can see here. We thank everybody for coming out. If you want a copy of the presentation, it will be available on our website. It's listed out in the link down there. CATI.com/SWW2015, 14, 13, those all work for previous presentations. And then if you want any of our stuff that we put out on a regular basis, Redneck Workarounds for our blog, CATI.com. And by the way, that is my shoe from last year at SolidWorks World. I blew out my shoe. Had to use the maintenance guy to put my shoe back together. Yeah. So we left those for the guys in San Diego, though.
All right.
All right. Well, thank you guys very much.
Thank you.